you get a 50-50 mixture of both isomers. And that is because, the reason for that is because it goes through a planar intermediate, and the hydroiodine can either come attack from above or below. So this is a little bit off topic, really. It's not really the aldehydes and ketones topic, but going back to year 12 stuff, going back to the electrophilic addition. And we can see here, sometimes you can also get this situation occurring with electrophilic addition where you end up with a racemic mixture. So let's have a look at that. So I'm going to start off with this this alkene. Okay, so that is what is it? It's a butene, isn't it? Yeah. Okay. So let's see. That's going to react with HBr. Okay. So remember, you've got a delta positive on the hydrogen there, and the first step in the mechanism is for the pi bond to break, and those pi electrons, they move on to that hydrogen and form a new bond there. Now, if you remember that the hydrogen is actually can either stick onto that carbon or it can stick onto that carbon. And if you remember, the major product is going to be when it sticks onto the red carbon there, because that means we're going to end up with a tertiary carbocation. So I'll show it what happens for the major product only, okay? Of course, this hydrogen has now got to break this bond here, so that pair of electrons goes back onto the bromine to form a bromide ion. So let's draw this intermediate. So we've got CH3 now, because the hydrogen is attached to it. We've got an H, CH2, CH3, and we've got Br minus here. That bromine has taken both the electrons from that bond. So that means if that was neutral, if this was neutral, sorry, if this was neutral and this was neutral, then, and you make something which is minus, that means that the other thing has got to be a plus. Okay, so, and it is, you've got a plus there on that carbon, and this is called a, if you remember, it's called a carbocation. Now the carbocation, let's think of the shape around this carbon. Okay, there are three groups around it, three bond pairs, no lone pairs, so that means it is going to be trigonal planar. Now you probably remember the final step in this mechanism is for this negatively charged bromide ion to react with the carbocation, and what happens is that pair of electrons goes there, and we will form as the product 2-bromobutane, okay? And we can see that this carbon here is asymmetric. You've got four different groups attached to it. You've got the ethyl, the bromo, the methyl, the hydrogen, okay? So it's asymmetric, and it probably comes as no surprise to you that which isomer is going to be formed. Well, it's both isomers formed, and both isomers will be formed, and they'll be formed in a 50-50 mixture. Sorry about that. They'll be formed in a 50-50 mixture. Both isomers, and that's called a racemic mixture. And the reason for that is, well, let's think that this thing here is planar, isn't it? Yeah, and the Br minus can attack from above or below. and each one is equally likely. If it attacks from above, you get one isomer, from below you get the other one. Why is it going to attack from above or below? Well, there's all these electrons from, all of these. The hydrogen's got some electrons, isn't it? Yeah. The methyl's all the electrons. That's the ethyl's got electrons. So it's going to go